Hello, my name is Tim Stewart, and I'm from Visual Decisions. I've been doing these webinars in this series for a while now. With me today, I'm happy to have Matthew Weinrich from Sandalwood. Matthew, if you could give yourself and Sandalwood a quick introduction, that would be great.
Sure. My name's Matthew Weinrich, and I've been working at Sandalwood for about the last 11 years, mostly focusing in systems like this part flow visualization that I'll be giving a high-level overview of today. I'm a systems integration engineer, so I've been kind of all around the design and implementation of these systems.
Excellent. I've been working with Sandalwood for a long time, and I can't recommend you guys any more highly than I already have in the past. So welcome.
Thank you.
So today we're going to be talking about part flow visualization. And to me, this is a really important topic. A lot of systems are out there looking at machine visibility and predictive maintenance and things like that. But there aren't a whole lot of people talking about how to visualize the flow of materials within the plant. So really interested in what you have to say today.
All right, I'll go ahead and get started here.
Yep.
So first, let's just kind of introduce part flow visualization, what it is, what it isn't. Like Tim was just talking about, the MES and SCADA systems are important and established parts of mature production floors, but often those systems have a blind spot. So they're focusing on machine level information, shift-based reports, quality data, things like that. That blind spot can be filled in by adding part flow visualization, either as an additional feature to an existing system or implementing it as a standalone system that provides this functionality. At the most fundamental level, part flow visualization is all about knowing where your production units, so that could be your final product or sub-assemblies, kits, things like that, wherever those are within the manufacturing process, all in real time. That real-time part is really key for the part flow visualization as well. Once you have a system that knows where those production units are in real time, you can use that data for a variety of purposes. Things like that intuitive bird's eye view visualization, so looking overhead to see the shape of your whole line, aggregating units in a particular area, and even things like playing back the movement of units during a particular shift or during a changeover. So now that you know what part flow visualization is, what kind of benefits can you get? So if you're watching parts move through a production line, or even just looking at a snapshot of where parts are at any given moment, you can reveal bottlenecks, whether that's due to an imbalance with an operation taking longer than other upstream or downstream operations, or things like a machine that's going down too often. When an operator can see what types of parts are approaching their workstation and when that will change, they can improve the accuracy of the operation by being prepared before the part gets to them. If you're flagging quality issues, you can also track where those issues started and how long it takes for a rejected part to make its way to a repair area, all of this reducing misbuilds. Similarly, a well-prepared operator will be more efficient at their operation than one that's needing to scramble for the correct tool or component. You can also see improvements in productivity at a more macro scale by knowing better how you can allocate the operators to workstations. When there's complexity of part types, workstations will inevitably need deliveries of components. So being able to see where different types of parts are on the line allows everyone on the plant floor to be more prepared for these delivery needs rather than needing to react and potentially stop the line when the need comes up. So that's reducing the emergency line-side deliveries. Once you have the underlying data recorded for a production line, you can also play back that data in a visualization to show how a particular shift went if you're trying to figure out why your production numbers weren't as high as they usually are, or if you're trying to see how the current line performs and a new model is introduced, for a few examples. So playback of historical scenarios can let you know how things already went, and then you can tie that into the simulation of changes in the process. So if you're trying to see what went wrong in the actual data that got recorded, you can then try simulating the line in a different scenario and see if that might be alleviating it. And then putting all of that together, part flow visualization lets you plan better for the future, from regular operations to logistics to changes to the way your line's designed.
Yeah, for me, being able to get visibility into the bottlenecks kind of in real time is really interesting. For a lot of companies, it's pretty obvious if you have just a straight line, assembly process or something like that. where the bottlenecks are happening, because you'll see it on that line. For companies that are more job shop based, it can be really hard to understand what the current bottleneck is within the site. And being able to utilize some of these tools to get visibility of that in real time based on the mix and who's working that day and everything else, I think is really interesting and really valuable.
Right. You can definitely correlate it with other things that are happening based on records that you have of, who's on the line, who's managing the line. If you have a higher or lower, workload on that particular shift, maybe your day shift is being more efficient than your second shift, something like that. And those are the kind of things that seems like you might be getting them just by looking at the machine level data, seeing like how many parts went through a station, but you can really get a lot more granularity by watching the flow through the stations rather than just seeing what was the count in an hour. Maybe there was one particular event that happened that really slowed it down, but they caught up later.
Yep. Yep. Excellent.
So you talked about what kind of benefits you can see, but also who's going to see these benefits? Who's going to be the champions in your plant, in your operation, who might see the benefits but might need to find out about the kind of benefits they'd see. So this can be across many different roles in a manufacturing environment. So kind of starting at the bottom with the operators. So at key operations that have complexity, you can have a dedicated HMI or terminal showing what parts are coming toward them. Depending on what their needs are, this could include information specific to the operation, so like what version of a subcomponent is needed for each model at this particular station. And you can aggregate batches of parts so the operator knows how many of each model to be prepared for before they arrive at their workstation. So really tailored toward, at the actual operator level, working on the part at their station, what's relevant for them, how does it affect them, trying to not look away from what they're doing, but really see what do I need to be prepared for so I'm not surprised. Next up are the material handling personnel. So they're going to be looking at the whip counts or the location of a batch on the line to be able to deliver materials proactively rather than reacting when a workstation runs out. So you might be trying to see when a batch is arriving toward a station so that you can deliver kind of the expected parts for the next batch without overloading the workstation with too much material just sitting there all the time. Or maybe there have been more parts that got stripped down and are coming back through as one-ofs that you're trying to get that material over to them, that you would think that the batch doesn't include this part type, but maybe that model is actually going to be relevant to that operator sooner than you thought. Maintenance personnel can see when machine issues are impacting the flow of the line, and if there are particular stations that need priority, if you have multiple machines down at the same time. So this is some of that overlap with some of the other plant floor systems. You might be able to see those machine states in another location, but seeing where all of those are located relative to the flow of parts can tell you, wait, there's a bunch of parts waiting for this one station. We need to really prioritize this one to keep the line flowing, whereas another station might be a little bit less time sensitive to get serviced. IT personnel would be mostly involved in a support role, but they can also get real-time information about things like when machines stop communicating by seeing the part flow in the system. If you're seeing that a machine has gone down, maybe there's a network issue, maybe if it's a whole section of the line, maybe it's at a team level or at a network switch level or something like that. And that's going to give some additional visibility even on that kind of macro level of the IT personnel. And then getting up to the top, we have plant managers. They're going to be looking for high-level conclusions, things like counts of parts in process or in repair areas, location of the batch in the line, areas of the line that are empty or backed up. They're more likely to look at the data presented in multiple ways, so toggling between that bird's eye view of the line, looking at tables with whip counts, and then looking at things like historical playback or simulation of changes to the line, trying to get a big picture view of this, not just looking at it from one perspective the whole time.
Yeah, and I could see a bunch of other groups utilizing this information either in real time or some of the historical information as well. The planning team you mentioned on the last slide, from a planning perspective, being able to utilize this information to see where parts currently are in the process, whether the plans need to be adjusted or anything like that. If you think about the supervisors and how they're managing their different areas, being able to see that flow is going to be very useful. And then even for things like the engineering team, if they're doing VSMs or anything else like that, being able to see how the material flows over time is going to instruct those projects much more accurately than just going off of intuition or memory, or going out to the floor and watching one path through the system. Being able to have access to that history is going to make those things much more accurate.
Right. You get access to a lot more data when you're really recording everything throughout the whole process, whether it's through a single line, or you might even be going from kitting into a sub-assembly line into a full assembly line. You can get that whole pathway for all of that knowledge. And of course, these roles are kind of a simplified bucketing of people into a few different roles, but there's lots of different ways that it can be used. And as you start using a system like this, you can start building in additional features that are really your particular use cases. Maybe you have someone that has a particular interest in one part of the process and you want to really beef it up, where you're trying to see, here's a pain point here. So one thing that we've sometimes seen is if there's one particular subassembly that's being installed that's easily confused, maybe you have a special screen where the operators can see this specifically without all of the other information distracting them. Maybe they don't care about the overall model, but they care about, I want to see which label of subassembly that I'm installing here, so that they don't have to do that level of translation in their head too. So now that we have kind of an idea of who's going to be benefiting it, what kind of benefits they see, now it's time to think about what's going to be required to have a system like this. So many of these elements may already be in place if you're adding to an existing plant floor system, but whether you're starting from scratch or enhancing existing technology, it's good to know what you'll need to have a successful part flow visualization system so you can have everything in place to be successful. So on this slide, we'll be focusing on the serialization and the networking. So serialization is vital for tracking part flow. You can really use any kind of formatting of serial numbers that fits your situation, but knowing that each unit has a unique ID allows the system to track part flow accurately and even correct for some data issues like missing a read at a previous station. So being able to tell which part is in which location really allows it to see each individual part's location, as well as all the aggregation that can come in for there to make sure you're not double counting or missing something. And then on the networking side, of course, you'll need everything networked together to make use of a part flow visualization system. So that's going to be talking about things like the plant floor devices, whether those are PLCs or you might be putting them together into an HMI, some edge devices, things like that, all going together to whatever servers that you have, and as well as the clients. So at the minimum, you want to make sure that any data sources can talk to the server hosting your backend and front-end software, and that user clients can connect to the server to view the visualization. Depending on your needs, the clients could be a variety of dedicated or shared HMIs, large boards or TVs hanging from the rafters, or just standing up next to the line. It might be in some of the team meeting areas. You could have laptops or desktops that could be in a variety of areas. And also mobile devices, so tablets or phones are becoming more popular. And depending on your use case, that might be a primary way of accessing this, or it might be something where you can just check on it while you're in between stations. Different situations may have different networking needs, and much of the client is scalable after initial integration. So you don't have to decide exactly what you want for all of those clients. If you decide that you want to try it out with just some laptops and desktops, so you're not really locking into place how clients are going to access it, you might find that you want it in more different places than you initially anticipated later. And that's usually a pretty easy thing to scale. If you already have all of the backend and data collection set up, you can kind of scale that client side after the fact. Moving next into the plant floor data. So plant floor data is where everything starts for a plant floor visualization system, and the accuracy of the system will always depend on getting accurate data from the plant floor. So one common approach is to have an RF tag reader at each station, so you see when a unit passes by each physical location. With this approach, you get more resolution by reporting part data from more stations, especially in locations that are spaced further from other read points. So obviously, if you have one read point right after another, that doesn't give you a lot of extra resolution. But if you have a long gap between there, adding another read point in between can show a real benefit in the accuracy. You'll also get more accuracy by ensuring to include data from any decision points where parts may be routed into parallel paths, regression paths, buffers, spurs, etc. So a key part is if you're using this fixed location to get data, you want to have them in as many places as possible, and you want to pay special attention to any time that a part can be routed in a different direction, so you can see as it's starting to get stuck in a repair area, needing to re-enter the line, if it's going off on a pallet or on a trolley, so you're getting it away from a production line. If you're stacking them up in a buffer, all of that's going to be easier to tell if you have those read points right where they're getting diverged. Another approach is if your units are moving on AGVs or similar carriers that are aware of their physical location using something like GPS. In this case, the units or carriers can broadcast their identity and location using some kind of wireless technology, so Bluetooth, Wi-Fi, RF, cellular, etc., to the system. With this approach, you can improve the resolution by transmitting more frequently. So in this case, your messages are going to include the identity and location at the same time, so they're kind of free moving throughout the plant, but you can find out where they are every time they broadcast it. If you broadcast more often, you can find out more resolution there. In either of these approaches, you would need the serial number and location at a minimum, and then including additional properties can provide more detail for users and enable other features like indicating rejected parts, color coding for different models, etc. This is one of the places where you can really add in some additional customization based on what data you collect.
What are your thoughts on incorporating video here? I've seen companies that have a lot of manual processes that utilize some of the video analytics systems in order to track some of the material movement as well. Is that something that you see as augmenting that plant for data collection?
Yeah, I think there are definitely opportunities for that. I think really you want to focus on, can you get this minimum data from that? So if you have, for example, a camera there that's doing a vision system and it can recognize from a QR code or from shape recognition or something like that what it specifically is, and have that serialization being sent out there, then having that additional context based on the video, not just the identity of them, can give you a lot of things like defects due to seeing something that's installed there improperly, things like seeing the usage of an operator. Maybe you're going to identify ergonomic issues if you can say, I'm going to now capture all of the cycles that were this individual model type. Maybe you notice a pattern there as well. So I would say that it's a good augmentation, but it's not a replacement for this. Make sure that you can always boil it down to the individual identities so that the system can track that, and then you can do that type of analysis.
Excellent.
Now getting into what kind of software you have to run all of this. So the software to run one of these systems can come in different forms, but there's two main components in any situation, whether these are all into one integrated software system or if you have a back end passing off to a front end. So on the back end side, you're going to collect all the plant floor data, perform any logical operations with that data. So some examples of operations the back end would do would be inferring unit locations in between read points, so making it look like a smooth animation rather than jumping from one read point to another if you don't have as much resolution in between your read points. Aggregating all of those individual units to give a count in particular areas, recording data for future playback, and returning search results. So if you're looking for where a particular part or particular batch is on the line, the back end will be able to give that information back so you can see where all of that is located. And the front end is going to define what the users will see. So any views that you have, widgets, how interactive you want it to be, how users can access it. So there's some common views. So that bird's eye view that I mentioned before, so showing the actual shape of the line, showing work in progress counts and tables, having an operator specific view. So those are some things that are often used, but the front end can be an opportunity to really tailor the experience to what your users need. You can always add some views that not everyone's going to see. If you have a really specific use case, you might find that one of these views is close to what you're looking for, but you want to add some information that's easy to see at a glance, and really just being able to access it in the way that you need. As you can see with those icons on the right, there's lots of different ways that a user might see it. You might want to have a different view when you're looking at it on mobile versus when you have it up on a big board, but you can present all of that data in a variety of ways.
Okay. I'm a lean manufacturing guy, and so I immediately see some, things that I would want to see in some of the front end systems around identifying, flow is one of the key principles within lean, of course. Being able to identify where my flow is not optimized and hesitating, delaying parts and so forth. The other thing that I think would be really useful is if you're looking for waste within the plant, being able to identify some of the waiting points, some of the excess transportation. Those are things that this kind of system will really help to highlight and be able to identify those and understand what's causing those things as well.
Right. You'd be able to see things like how many parts are in a buffer, how long they're staying in a buffer, whether you're getting things redirected to a buffer in a situation that you wouldn't normally expect. So, maybe you're thinking that it's only going to be used when there's changeovers happening, but you're seeing it happen more often due to a machine being down or not having enough operators in an area where they're, one operator is having to move from one workstation to another to advance the flow.
Could you apply the same type of kind of spatial computing to some of the people movement as well? So that if you're doing a SMED setup analysis, setup optimization, you could do some spaghetti charting and things like that using some of these similar techniques.
Yeah, you could definitely do that. I think that you're looking at collecting a different set of data up front, but if you're having, badge in, if you're looking at operator inputs on the different HMIs and things like that, you'd be able to get the proper background data to be able to track things like that.
Cool.
So similar principles, but you'd be looking at different inputs to be checking that it's the person doing it rather than the parts actually flowing on the line. So you might want to separate that system or make it be a separate data flow within the same system, but you could do similar techniques.
Yeah, I was just thinking that as you're implementing some of those data collection things on the shop floor, obviously you'd want to segment the data and tag it appropriately and so forth. But some of those same data collection techniques could be utilized for people movement as well as part flow.
Right. And you could do the same thing with the material handling as well. If you're tracking the vehicles that people are driving to deliver those, you could be looking at their movement the same way that you could be with like AGVs. If you're tracking the locations of those, seeing if there's a clear path to get to those, if they're running into more obstacles getting to their intended delivery location than expected.
And track when they're moving without materials to look at the deadhead percentage and things like that as
Right.
well. Very cool.
So finally here, we're going to talk about where to get started. So, we've been talking about what the requirements are. You might be part of the way there. You might be starting from scratch. You might have a pretty mature system that you're trying to add this functionality onto. So if you want to think about how to get from where you are now to getting started with a part flow visualization system, it's good to start by asking yourself some questions about what you already have and what your plans are. So first, take a look at what data you already collect. So data like serial numbers are common to be tracking, so you might already have some of that data that you'd want for part flow, even if you're not tracking the part flow right now. You might have it in like a quality system or something like that. You may also already track other types of data you'd want to display or search for, so you can plan on how you may want to use that. So you can think about what's relevant for you. Are your parts really grouped into distinct models where you have big batches of them? Do you have a larger kind of macro product where you're basically tracking what types of subassemblies are installed on it to tell the difference? You can take a look at what kind of data you want to collect, what you're already collecting, and what you would want to display. And take a look at what systems you already use. So if you're already in an ecosystem like Ignition, the approach for adding part floor visualization may be different than if you're starting from scratch. Additionally, if you have a complementary system like a quality system, you may be able to plan for incorporating that data into the front end that shows part flow. So you don't necessarily need to replace existing systems. You might be able to add on to them or build the system in parallel and share some of that data. I want to take a look at what your plans are for maintenance and growth. So factors like how many production lines you have and how big your staff is can affect how robust of a system you'd want. So with more complexity and reusability at your site, you may want to make more of an initial investment to be consistent across multiple lines and avoid rework later to add features. Or if you have a smaller footprint, you may opt for a simpler approach. So we've kind of talked about the minimum data that you'd want to get, but also where it can grow to. So try to think about what you would want there and how much you want to invest up front versus trying out some of it and then letting it grow over time. I'm going to take a look at how much detail you'd want to see now or in the future. So you can think about any specific needs your team could use help with. So some details might be superfluous in one context, but are really vital in another. And finally, you don't need to figure this all out on your own. You can let Sandalwood share our experience and expertise in this area to help you plan for a solution that meets your specific needs. As we mentioned, there's a lot of this that can be really tailored to your specific situation, and we can help guide you through that process of figuring out how big or small it makes sense to kind of kick this off with and find something that fits right for you. And on that note, here's some information about how to contact us. So if you want to reach out to us, feel free to reach out and find out more. Thank you for listening.
All right. Thank you, Matthew. Great presentation. I think this is, like we talked about, a very important topic that's really relevant in most manufacturing facilities. So I highly encourage anyone in the audience that's interested to reach out to Sandalwood at any of these different contact points. And if you want, reach out to me as well. Thank you again, Matthew. Hope you would join me again in the future to talk about another topic.
Yeah, thank you for having me.
All right, thanks.